Dear students, my name is Sir Komel, and today's the topic of my lecture is energy band diagrams of insulator, semiconductor and conductor. Before starting the lecture, I would like you to request to kindly subscribe my channel and click on the bell icon so you always notify me whenever I upload the new videos. Now I am starting the topic. You can see on the shared screen there are three band energy diagrams of insulator, semiconductor and conductor. First of all, I would like to define you conductor. What is a conductor? Conductor is a material which conducts electric current. The material in which the resistance is minimum and there is no hindrance for current to flow, that material is a good conductor. Like iron is a good conductor. Like copper is a good conductor. What is insulator? Insulator is called poor conductor. That is the material which has the resistive properties, maximum resistive properties, and there is a lot of hindrance for current to flow through that material. That material is called an insulator. Like rubber, water, plastic, wood, these all are insulators. What is a semiconductor? Semiconductor is basically, you can say, half conductor and half insulator. It conducts current, but not like a conductor conducts. It conducts current, but it also insulates it. Why? Because semi means half. It means it is a half conductor. Semiconductor is the base of electronics. Like silicon is a semiconductor material, germanium is a semiconductor material, arsenic is a semiconductor material. Electronic devices are based on semiconductor. So these band diagrams represents the conductive properties of conductor, insulate, insulative properties of insulator, and the semiconductive properties of semiconductor. Now first see the figure A, which is the band diagram of an insulator. The arrow is showing energy levels. Arrow is pointing upward. It means in the upward direction energy is increasing. There are two bands, conduction band and the valence band. Conduction band is the band in which electrons jump towards. When the electrons jump from valence band towards the conduction band, actually the current is flowing when the electron jumps from valence band towards conduction band. But it is not for easy. It is not so easy for electrons to move from valence band towards the conduction band. There is a lot of band gap. There is a lot of amount of energy which is to be given externally to an insulator so that electrons of insulator will be able to jump from valence band towards the conduction band. So you can see there is a great band gap of energy between conduction band and valence band in figure A. This band gap of energy is basically the amount of energy which is to be given externally to an insulator, to an insulative material. Then the electrons of insulator present in valence band will be able to jump towards the conduction band. So it is practically very difficult to give a large amount of energy externally to an insulator. That's why the band diagram of insulator is showing you a huge band gap between conduction band and valence band. Now look at the energy band diagram of semiconductor. Conduction band is above the valence band on energy level, but there is not a huge band gap of energy between conduction band and valence band, like you see in the diagram of insulator. There is a huge band gap, but in the diagram of semiconductor there is not such as huge band gap that it was in case of insulator. That's why semiconductor is called semi-conductor. So it is a little bit easier for semiconductor to conduct current in comparison with an insulator. There is a less band gap of energy. It means less amount of energy is required, which is given externally to a semiconductor, so that electrons present in the valence band of a semiconductor will be able to jump towards the conduction band. So semiconductor, that's why it is called the basis of electronic devices. It is called the basis of electronics because electronics is the field in which there is cases of low voltages and low currents. You already know electronic devices, electronic machines, electronic instruments. These all work on low voltages. And in electrical, there electrical machines, electrical devices, electronic components works on high voltages, high power, low power. This is the difference between electrical and electronics. That's why electronics totally based on semiconductor. So there is a less amount of energy required in case of semiconductor to enable the electrons present in the valence band to jump towards the conduction band. Now you see the band diagram of conductor. You see the band diagram of conductor. There is no band gap of energy. Conduction band is overlapping with valence band, i.e., there is no band gap of energy. No energy is required externally to give to the conductor so that electrons present in the valence band start conducting the electrical current and move towards the conduction band. There is no such band gap of energy. So no energy is required externally to give to the conductor. Conductor is a good conductor of electric current. If you give the electrical current to any conductor material like iron, copper, then it will surely conducts. So these are the three band energy diagrams of insulator, semiconductor, and conductor. Give me the comments, give me the feedback. If you like the lecture, subscribe my channel and click on the bell icon and wait for the next video. Thank you.